All right, welcome. So today we're diving into something huge, a real fundamental shift in how we establish technical trust. Think about it. We're moving away from this old world of just trust me and into a brand new era where proof isn't just a piece of paper, it's code you can actually run.
This quote right here, it just nails the whole philosophy we're unpacking today. It's such a powerful idea. I mean, what if you didn't have to just take someone's word for it? What if you could literally run a command and see the proof for yourself? Well, that's the future we're talking about. Okay, so let's set the stage here. What's the actual problem we're trying to solve? For decades, right? Security and compliance have been built on this trust me model. Somebody shows you a PowerPoint, hands you a document, and you're just supposed to believe that what they claim is true. But that whole model, well, it's really starting to show its cracks. And this really breaks it down, the two different worlds. On the left, you've got that old school claim-based trust. It's totally reliant on static stuff, like slide decks. It's so brittle. I mean, the second you change something in your system, that whole presentation is just useless. But on the right, that's the new way, evidence-driven trust. It's built on scripts that give you proof you can check again and again. It's resilient because it's always tied to reality. And this is why it's so important. People on the outside, auditors, regulators, investors, they can't operate on your company's tribal knowledge. They have no idea about that one shared drive where you guys keep all the real compliance docs. They need a systematic, repeatable way to find the evidence themselves. They need proof, not promises. Okay, so how do we actually build this kind of evidence-driven trust? Let's get concrete and look at a real solution. It all kicks off with a simple but seriously powerful PowerShell script. Seriously, think of this thing like a tiny digital auditor you can just hand to someone in a single file. Now the real secret sauce here, the magic, is this principle called zero assumption discovery. Basically, the script has no idea how your project is laid out, and it doesn't care. It doesn't look for a folder named compliance. Instead, it actively hunts for evidence, kind of like a real human auditor would. And that's what makes it so incredibly robust. So let's trace what it's actually doing, step by step. First, it finds the root of the project, all by itself. No cheating with hard-coded paths. Then it starts searching for files that look like evidence. Things with words like compliance, risk, or audit in the name. It also checks for the really important stuff, like automated enforcement in your CI/CD pipeline, and looks for things like risk registers. And for the grand finale, it makes a cryptographic hash of a key file to prove its integrity. And only then, only after all that, does it give you its final statement. And here you can see it in action. It's not looking in one specific place. It's doing a deep search for those keywords. What this means is you can totally rearrange your project, move files all over the place, and guess what? The script doesn't break. It still finds the evidence. Trust is now linked to what's actually there, not some fragile file path. That's huge. And this is the payoff, the final output. See how it comes full circle? It's not just saying, hey, it worked, or success. It's reinforcing that core idea we started with. It's not asking for your trust. It's stating as a fact that it has provided you a way to verify things for yourself. The process is the proof. Okay, so a single script is cool for a demo, right? But to make this actually useful in the real world, you gotta level it up. The next logical step is to turn it into a proper, reusable tool, a command line interface, or a CLI. And you can see that evolution right here. On the left, you've got the raw script, which is kinda clunky to run. But on the right, it's been packaged into this beautiful, clean command. All that messy script stuff, gone. It's hidden away, and what you're left with is a command that's just clean and obvious. And the benefit of doing this? It's massive. By making it a simple command, verifying trust is no longer some specialized, painful task. Your auditor can run this. Your new business partner can run this. You can even stick it right into your automated test pipeline to make sure that trust never, ever breaks. So running a command is one thing, but auditors, they need a takeaway, right? Something they can pack in their digital briefcase. This is where the process creates its most valuable artifact, a totally self-contained, tamper-proof report. But hold on a second. This brings up a super important question, doesn't it? In a world of deep fakes and digital manipulation, if we're trying to get away from trust me, how do we know someone didn't just, edit the report file to make it look good? How do we trust the proof itself? Well, the answer is simple. And honestly, it's pretty elegant. It's cryptography.
We use the same battle-tested technology that secures things like global banking to lock down our little trust report. So here's the deal. The tool doesn't just spit out one file, the JSON report. It creates a second file too, a cryptographic signature. Think of that signature file like a digital wax seal on an envelope. If you break the seal, if you change even one comma in the report, everyone knows it's been tampered with. The signature becomes invalid.
So you might be wondering, how does that signature magic actually work? Well, it's a pretty classic process. First, the tool calculates a unique digital fingerprint, that's the hash, of the report. Then it uses a top-secret private key to sign that fingerprint, which creates the signature file. Now, anyone with the public key can come along and prove two things: that the signature is legit and that the report is exactly as it was when it was created. And look, this isn't some black box magic happening behind the scenes. The whole process is transparent. You can see the exact command used to create the certificate that holds those keys. It's all out in the open. Nothing's hidden. Okay, so let's zoom out for a second and look at the big picture here. This whole approach gives us a really powerful new way to think about trust. And we can boil it down to 4 key ideas, 4 dimensions.
This table is awesome. Think of it like a trust lens you can use to evaluate any system. You just ask these 4 questions. 1. Is it discoverable? Meaning, can you find the proof without needing insider knowledge? 2. Is it deterministic? Will you get the exact same result every single time you run it? 3. Is it portable? Can you share the proof easily? And finally, 4. Is it verifiable? Can anyone check the crypto signatures on their own? If you can answer yes to all 4, you're talking about a system that's in a whole different league of trustworthy.
When you boil it all down, it comes back to this simple but profound shift in how we think. The moment we start treating trust verification as just another piece of code, we stop asking people to believe us, and we start giving them evidence they can check for themselves. This completely changes the conversation for audits, for due diligence, for everything.
And that really leaves us with one last question to chew on. Now that we know this is possible, now that we know we can build systems where trust is something you can execute and verify, why on earth would we ever go back to just settling for a promise?